Hello, fourth graders. Today for math, we're going to be finding the area of composite figures. Now, as a reminder, a composite figure is a figure or a shape that is composed or made of rectangles and squares. And in that word composite, you should hear compose, and compose means to put together. I can add a prefix to the beginning of that, D, and make it the antonym of decompose, to take apart. And these words, compose and decompose, we're going to be using in these conversations that we'll have as we work with polygons or composite figures. We're going to decompose them and compose them. So let's try this out so you can see what I mean. So we're going to just take a quick moment to review finding the area of a basic figure, a rectangle or a square, using our formula, area equals length multiplied by width. A equals L times W. So I'm going to start actually with this tall, skinny rectangle on the left. All right, I'm going to fill in what I know in my formula. I'm going to be finding the area, so I don't need to fill anything in there. The length, the longer side, is 15 inches, multiplied the width, that shorter side, the width is 2 inches. So I have A equals 15 times 2. 15 multiplied by 2 is going to give us 30. Now, we need to make sure that we are putting in our units properly. Remember, area is the measurement of the inside space of a figure. So we're measuring this with square inches or inches squared. Okay, so you'll either hear square inches or inches squared. Let's check out the square that is next to it there. I have 11 inches as one of my measurements. So A equals a length of 11 inches. And if it's a square, that means every single side is exactly the same measurement. So its width is also going to be 11. So 11 multiplied by 11 is going to be 121. 121 what? Well, this is also going to be inches squared or square inches. All right, because of the fact that it's a measurement of that surface area inside the figure. Okay, I do want to point out, I'm going to switch to my pen real quick, that when we write this, you might also see IN, okay, so for inches, with the little 2 hanging right above it, that's indicating square inches, okay? That 2 indicates squared. So I can take these two figures, I've got a rectangle and a square, and I can actually combine these two quadrilaterals to make my own composite figure or polygon, and combine their two areas. So let's see, I'm going to actually take both of these and I'm going to put them together. Maybe I'll put them together like this. Okay, it kind of looks like a boot or something. So now I've made myself a composite figure, and I happen to know the area of both of these quadrilaterals because I found them already. So I'm going to go ahead and write them on the inside here. So I have 30 inches squared for this tall, skinny rectangle. And I have 121 inches squared for this square here. And since I've combined these two figures to make my own new composite figure, I can actually find the combined area by simply adding together, okay, 121 plus 30. If I add together those two areas, I will have the combined area of my entire composite figure. So 121 plus 30 is going to give me a combined area of 151 square inches, or inches squared. But what if we start with the composite figure or polygon? All right, in this last slide, I actually made one. But what if we actually start with a composite figure? How do we find the area of that composite figure? Well, there's a couple steps that you can follow. So first step is that you're going to want to decompose the composite figure into smaller rectangles. Decompose, what does that mean? Yeah, decompose means to take apart. All right, so I'm going to look at this composite figure or polygon, and I'm going to decide, okay, where could I kind of break it apart where I'm going to end up with two smaller rectangles? And I can do it two different ways, but I think what I'm going to do looking at this right here, I'm going to break apart this one little piece there and then the larger rectangular piece there. So notice what I did. And if this was just a drawing that was in front of me, not a little manipulative like I actually have right now, if it was a drawing, I mean, I could just go ahead and pencil in a little line, show, okay, that's where I'm breaking them apart. All right. So I'm going to separate out those two. I'm going to decompose the composite figure into smaller rectangles. So that's the first step. Once I've done that, the next step is to use our formula, area equals length times width, to find the area of each of the smaller rectangles. So I'm breaking it apart, and then I'm going to find the area of each of those smaller rectangles. All right, so let's look at this one on the left, the smaller one that is here. I'm going to fill in what I know as per usual. So the length is going to be 4 feet multiplied by a width of 2 feet. Do you notice how I write out everything? Even if I'm typing, I write it all out, so I'm keeping track of it. So my area of this smaller rectangle, 4 multiplied by 2, is going to be 8, okay, square feet. So 8 square feet for that smaller rectangle. And then let's go to the larger rectangle that is over here. Let me just get that. There we go. My larger rectangle has a length of 12 feet multiplied by a width of 3 feet. So 12 multiplied by 3, 12 3 times, is going to give you, I hope you said 36. It's going to give you 36, and our units again are going to be square feet or feet squared. Okay, so now we found the area of both of these rectangles. So our next step after this, now that we've found the area of these two rectangles, our next job is to add together the areas of the smaller rectangles to find the combined area of the entire composite figure or polygon. Okay, so notice in my picture here, I've actually kind of put back together my composite figure the way it was originally. I'm going to go ahead and write in on the inside of the composite figure. I'll write in the areas that I know. So I know this smaller rectangle had an area of 8 feet. I always like to write out and label everything. So this is 8 square feet. And the larger rectangle was 36 feet squared. Okay, and I'm going to add together those areas. So I'm going to add 36 square feet plus 8, and that's going to get me my combined area. So 36 plus 8. All right, I take 4 from 8 to make 40, and then another 4. So I end up with 44. And the last part of this is that we have to label our correct units. So I'm going to write A for area. Area equals 44 square feet. Okay, feet squared. So as a review for our steps, what did we do? Okay, to find the area of a composite figure or a polygon, we decomposed the figure into smaller rectangles. We found the area of each of the smaller rectangles. Then we added together the areas of the smaller rectangles to find the combined area. And lastly, we labeled our squared units. So 4 steps to success in finding the area of a composite figure or a polygon. We're going to try 2 more examples here. Okay, so here's our steps up at the top. Decompose, find the areas, add the areas, label your square units. We'll go through all of these steps. So here's my composite figure right here. Notice I have got some lengths and some widths that are labeled. I have just enough that I can work with right now. First job, I'm going to decompose this figure into rectangles. There's a couple ways I could do it. Right now, what makes the most sense to me would be to make a break right along there. So that's indeed what I'm going to do. I'm going to go ahead and I'm going to separate out these two rectangles, the large rectangle and the smaller one, because I'm going to work with them now that I've decomposed this. I'm going to work with them separately, and then I'll combine them back together again. So I decomposed. Next step, find the areas of the smaller rectangles. Okay, so let's go ahead and we're using our formula. Area equals length multiplied by width. I'm going to fill this in. I'm still finding the area. Length, that longer side, is 18 inches multiplied by width of 10 inches. Okay, 18 multiplied by 10. This is a multiplication pattern. All right, so I can think 10, 18 times. I've got my 18. I can add 1 0 onto the end because it's 18 tens. So that gives me 180 inches squared, or squared inches. And let's take this smaller rectangle now. Oops, let me go back over here. Here we go. I'm going to do this. I'm going to take my smaller rectangle now, and I'm also going to find the area of that smaller rectangle. My formula, as always, length multiplied by width. Okay, the area is length, 8 inches, multiplied by a width of 2 inches. 8 multiplied by 2 is 16, and my units are inches squared. Okay. So I found the areas of the smaller rectangles. Next step, we have to add the areas of the smaller rectangles. So I have 16 square inches. I'll go ahead and change the color of that so we can keep track of it. And I have 180 square inches. Okay, these are my two areas that I just found. My next task is to combine those together. I'm going to add those together. So we'll do 180 plus 16, and 180 plus 16 is going to give us a combined area of 196 inches squared. So our final combined area is going to be 196 inches squared. I decomposed my figure. I found the areas of each of these smaller rectangles. I combined them together again, because remember, this was originally one combined composite figure. And then I labeled my square units. Let's try one more example. I have one last example here. Here we go. Okay, again, same steps. Decompose your figure into rectangles. Find the areas of the smaller rectangles. Add the areas of the smaller rectangles. Label your square units. So check this out. This one's going to look a little bit different. Something that you should notice is that part of this figure has some little tick marks on it. So if you look right up here, there's some little tick marks here. And remind yourself of what those mean. Okay, if I see little matching tick marks, that's going to tell me that each of those sides is going to be the same length. Okay, and I can put it together. I can infer here that this part of the composite figure would be square shaped. All right, so I'm going to, in my decomposition of this composite figure, I'm going to imagine that this is the break. That's the break that I want to use. I could do it otherwise, but this is the break I want to use. So I'm going to actually pull this off, put this over here. I'll get rid of this little guy. And then I have this part of the figure as well. So these are the two pieces of the composite figure that I'm going to be using. Find the areas of the smaller rectangles. Okay, well, let's go ahead and tackle this one on the left. Okay, area equals length multiplied by width. Okay, we're finding the area. The length here is 20 yards multiplied by 9 yards. 20 multiplied by 9. 2 times 9 is 18. And 1 0 from the 20. So we have 180 yards squared. Over here for my square, I'm going to go ahead and find the area of this square. Area equals length multiplied by width. I'm finding the area. The length is 8 yards multiplied by the width. The width is also 8 yards because it is a square. So the area of that square, 8 multiplied by 8 is, you got it, 64. And this is 64 yards squared, or square yards. Okay. Last step. You remember what the last step is here? Very last thing that second to the last thing that I have to do is I need to add together those two areas of the smaller rectangles. These two rectangles were originally together, right? So now I have to combine together those two areas in order to find my combined area. All right, so what I'm doing really is I'm saying, okay, I've got my 64 here, my 64 yards squared, and my 180 yards squared here, and I need to add them together. So I'm going to add together 180 plus 64, and when I add them together, that will be my combined area. So 0 plus 4, 4, 8 plus 6, okay, 8 plus 6 is going to be 14. Regroup a 1, 1 plus 1 is 2. So our final combined area of this composite figure, A equals 244 yards squared. I'm just going to put YD with a little 2 up on the top to show squared. All right. I encourage you, if you need a little more practice with this, just go back over the last couple of problems again, and then try your hand at the exit ticket for today's math lesson. All right. Nice job. Thank you so much, friends.